Confidence intervals. Let's go ahead and start right away with your student notes. First, let's look at a reminder of inferential statistics. Inferential statistics use a process of estimation, estimating the value of a parameter from data obtained from a sample. For instance, for each dollar you pay in the county property tax, 22 cents covers the cost of incarcerating prisoners. 8% of people surveyed in the United States said that they participate in skiing in the wintertime. These results were obtained from data collected from samples of large populations. So these values are estimates of the true parameters. Common assumptions must be met before valid conclusions can be made. Some of these assumptions are: the samples are randomly selected. The sample size must be at least 30 or the population must be normally distributed. You can use a histogram to see if it's approximately bell-shaped and check for outliers. Definition of confidence interval. A confidence interval is a specific numerical value estimate of a parameter. The best point estimate of the population mean, mu, is the sample mean, x bar. The sample mean is used instead of the median or mode because means of samples vary less than other statistics when many samples are selected from the same population. Good estimators have the following properties. They are first unbiased. The expected value or the mean of the estimates obtained from samples of a given size equal to the parameter being estimated. 2. They must be consistent. For a consistent estimator, as sample size increases, the value of the estimator approaches the value of the parameter estimated. 3. A good estimator is a relatively efficient estimator. Of all the statistics that can be used to estimate a parameter, this estimate has the smallest variance. Statisticians prefer to use interval estimates because the sample means are somewhat different from the population mean due to sampling error. Interval estimate. An interval estimate of a parameter is an interval or a range of values used to estimate the parameter. The estimate may or may not contain the value of the parameter being estimated. A degree of confidence must be assigned before an interval estimate is made. This is a percentage stating how confident you want to be, and that the interval does contain the true population mean. The interval for 95% confidence is not as wide as the interval for 99% confidence. To increase the confidence that the true population mean is in the interval must be made wider. Confidence level. The confidence level of an interval estimate of a parameter is the probability that the interval estimate will contain the parameter, assuming a large number of samples are selected and that the estimation process on the same parameter is repeated. Confidence interval. A confidence interval is a specific interval estimate of a parameter determined by using data obtained from a sample and by using the specific confidence level of the estimate. The interval estimate is based on the central limit theorem that states that when the sample size is large, approximately 95% of the sample means of the same size samples taken from a population will fall within plus or minus 1.96 standard errors of the population mean. That is, mu plus or minus 1.96 times sigma divided by the square root of n. Remember that z-values that separate the middle 95% from the outer 5%, 2.5% on each end, of the normal distribution are the critical values plus or minus 1.96. When a specific sample mean x bar is chosen, there is a 95% probability that the interval mu plus or minus 1.96 times sigma divided by the square root of n contains x bar, and there is a 95% probability that the interval specified by x bar plus or minus 1.96 times sigma divided by the square root of n will contain mu. Another way to think about this is the following interval. Notice how mu is in the middle of this compound inequality. Where on the left-hand side, we're taking the sample mean and subtracting 1.96 times sigma divided by the square root of n. And on the right-hand side, we're taking the sample mean plus 1.96 times sigma divided by the square root of n. These are constructed for all possible sample means. X bar, 95% of the intervals will contain the population mean mu. The confidence level determines the critical values of z that are used to find the confidence interval. We're going to go ahead and use table E or technology like your graphing calculator to find the critical values plus or minus z with the subscript alpha over 2 for different confidence intervals. Alpha represents the total area in the two tails, so alpha over 2 represents the area in each tail. The confidence level is 1 minus alpha. When alpha is 0.01, then 1 minus alpha equals 1 minus 0.01, which is 0.99. Here's the formula for the confidence interval of a mean for a specific alpha when sigma is known. As you can see here, we go ahead and use the compound inequality, where on the left side we have the sample mean minus the critical value of z subscript alpha over 2 times the sampling error, which is sigma over square root of n, where on the right side we still have the sample mean, but this time we add the same value. This compound inequality is used when we want to have some level of confidence that the mean is somewhere in between. Here are some examples of common confidence levels. As mentioned earlier, the 95% confidence level corresponds with the number 1.96. Let's take a look at the definition of margin of error. The term capital E equals z subscript alpha over 2 times sigma over the square root of n is called the margin of error or maximum error of the estimate. It is the likely difference between the point estimate of a parameter and the actual value of the parameter itself. Now, the margin of error depends on the following factors. First, population standard deviation. The normal distribution can be used to find the confidence level when the population standard deviation is known. Confidence level. If a large number of intervals are constructed, the confidence level represents the expected percentage of intervals that would contain the parameter. Sample size. The margin of error decreases as the sample size increases.